about that how we can get output of regression without running regression in Excel. We can get these regression results without running regression that is available in data analysis. First of all, we will discuss that how many formulas are used to get this output. For example, the first part is multiple R. The multiple R we can get with the help of correlation between Y and Y hat. Now the question is that how we can get this Y hat. Y hat means Y estimated. To get Y estimated, first we get A intercept and then B intercept. But before getting A intercept, because in A intercept we have I bar minus beta, beta hat X bar. So first we calculate this beta hat and the formula, we have number of formulas to get this slope. Now after getting this alpha hat and beta hat, we put in this regression model y hat alpha hat plus beta hat x, and in this way we can get this y hat. And when we calculate the correlation between y and y hat, the manual formula of correlation is this one, summation xy minus summation x into summation y divided by standard deviation of x into standard deviation of y, or covariance between x and y divided by standard deviation of x and standard deviation of y. The next is r square. In R square, because we have ESS and TSS, explain sum of square and total sum of square, and the R square can be calculated by 1 minus residual sum of square and total sum of square. So how we can get these ESS, RSS, and TSS? After getting this Y hat, first we calculate U hat, and U hat is calculated as y minus y hat, and then we will take its square. And after taking the square of u hat, and when we add, because these are zeros and we are taking sum of square, that is called RSS, and it is represented by summation y minus y hat square or summation u hat square, or we simply may call it as RSS. After getting this RSS, then we can calculate ESS and TSS, and the formulas are y hat minus y bar square, and then basically we'll take sum and then sum of y minus y hat square for TSS, and TSS is equal to ESS plus RSS. And now how we can get this adjusted R square? For adjusted R square, before discussing these R square and adjusted R square, first we calculate standard error. Standard error is calculated by summation U hat square that I have already discussed, this one, divided by n minus k. N is total number of observation, while k is number of parameters or estimators. Uh, Now after getting this as, then we have ANOVA. Now in ANOVA, we have regression that is represented by E, the residual that is represented by R, and the total that is T. Here we have degree of freedom, k minus 1 means number of parameters minus 1, total number of observation minus number of estimated, that is n minus k. If we add, we can get n minus 1. Then ESS, here E and its here heading is S, so it is ESS. Then this location is RSS, then TSS. Now then we have mean ESS and mean RSS, mean real. How we can get? We divide these variances that we have calculated by their degree of freedom. We can get these mean ESS, and how we can get F? F is basically mean ESS divided by mean RSS. Now here in adjusted R square, we have the formula I have already explained that R square, in R square we have 1 minus RSS or TSS or ESS divided by TS. In adjusted R square we have 1 minus T minus 1, total number of observation minus 1, we may call it TRN, or N minus K multiplied by 1 minus R square that we are getting from here. And then we can use another formula adjusted R square, that is 1 minus average RSS and average TSS. It's just like this one, R square and then adjusted R square. For example, as you can note to these notation. Then we have total number of observation, that is N. Now I have already explained this ANOVA because these are variances formula, that's called it as analysis of variances. And then we have coefficient A hat and B hat, I have already discussed that with the help of these formula alpha hat and beta hat. And then we have standard error of alpha and standard error of beta. How we can get for standard of alpha, we have S that we have already calculated here, S with the help of this formula, and then we're using summation x square and summation x square minus summation. When we multiply after taking its under root, we multiply it by S, we can get standard of alpha. In the same way, we can get standard of beta. The formula, the S is the same, but here the 1 divided by summation x square minus n x bar square. In this way, we can get standard of alpha and standard of beta hat. Now T is basically calculated coefficient divided by standard. If we divide alpha hat by standard of alpha hat, and in the same if we divide beta hat by standard of beta, we can get this one. And then the next is that how we can get lower limit and upper limit. For lower limit, we need critical value. Now critical value of T statistic can be obtained by using T inverse 2 tail, but remember that you should take positive T value, and with positive we can take absolute of T value. Next, for P value, in the same way we can get critical value for F distribution, that is F inverse right tail, by using this. Here we have 2 degree of freedom. The one is this one, k minus 1, and the other one is n minus k. And in lower limit, we have alpha hat minus critical value multiplied by standard. Now we have all these. Alpha hat is here, standard error we have already calculated and placed in this location, and then we multiplied by critical value. In the same way, by putting plus, we can get upper limit, and by putting minus between these two terms, we can get lower limit. In the same way, we calculate lower limit and upper limit for beta. So it is all about that how we can get the output of regression model without running regression model. The one thing that is remaining, that how we can get p value of f. P value of can be obtained by using this formula, that is f dist right. Thank you very much for watching this video. In the next video, I will explain all this procedure with the help of data. Thank you very much.